Okay, what's happening? Oops, let me get this real quick. So this is a GeoGebra window set up with the problem that we just did. You can see f of x is x squared, and this little bit of code here will, you can see they're at the midpoints, and that's what this slider is. If I slide this to the left, you can see now the left-hand corner is on the line, and if I slide it to the middle, you can see that the middle of the rectangle is on the line, and if I slide it to the right, you can see that the right-hand corner is on the line. You can see the approximation for the area changes as I move it back and forth. It goes up to 14, which is obviously too much. You have all this over, and you can move it back to here. And again, this is an underestimation, so it was good that we used this middle, the 0.5. There we go, okay? And we got 8.75. GeoGebra agrees with us. You can also do trapezoids. So let me make these trapezoids, and you can see, boy, that looks a lot better. It's still going to be a little bit over because you have, you know, that little extra bit of green up there, but it's much better than the rectangles. It's much more visually appealing. But probably the best thing we can do, really, is just add more triangles. So here I have 3 triangles. Let's double that. I'm sorry, rectangles. And let's double that. Let's go to 6. Okay, and now you can see that I have more rectangles here. And instead of the width of 1, they each have a width of 1/2. Width of 1/2, width of 1/2, and they still go up so that the midpoint hits that line. You can see the new approximation, 8.9. I can just keep adding rectangles. Okay, and you can see my value of the area is getting very close to 9. Let's make them trapezoids even better. Trapezoids are going to be a little bit over, so the area is probably going to be 9. So we can use computer software to increase the number of rectangles to get a better idea of what the area is under the curve. And again, this is approximation, but you know, with computers, we can just add as many rectangles as we need. So when it talks about that computer software, you can do this. And this is available on MrSankey.com. Go to Geogebra and find the rectangular approximation method.